Hello students, welcome to the class. Today we are going to start our discussion in the mechanics section, that is the rotational dynamics. Rotational dynamics appears to be difficult for the students, but it is not actually difficult. It is comprises basically some previous concept understanding in a better way. Then it will be appearing in the same level. It has the same level of difficulty that you can observe in the other chapters. So it is not so that it is related with your circular motion, kinematics, Newton's laws of motion, and therefore those concepts are also being used here, and so in a virtual manner it appears difficult. See, for understanding the rotational dynamics in a proper way, what is required? Kinematics should be clear to you people, then laws of motion should be clear to you people in a better way, and also the circular motion should be clear to you people. So here it is just the discussion of those matters and their application in some different way, so we can understand it in a better way. There is no such thing so that you can get horrified. No need of getting confused about the matter that it is difficult. So let us begin our discussion with the understanding of rotational dynamics. You very well understand that mechanics has two sections. One is the statics and one is the dynamics. In the statics section, we don't read and understand and don't try to put attention on the matter like what is the cause of motion. But in dynamics section, we definitely understand the cause of motion. We definitely consider the cause of motion, that what is the cause of motion. So rotational dynamics is also known as your rigid body dynamics. Here there is a general meaning of rigid body that you all understand, that rigid body which is a hard body, but in physics its understanding is somehow different, and we have to understand that thing in a proper way. In a rigid body, what is required? The basic purpose is there. Ideally rigid body is not available, but for all practical purposes we will try to consider the normal rigid body as the rigid body, in which the main thing is there to understand that if this is a rigid body, the distance between 2 points A and B remains the same whether the force is acting on it or the force is not acting on it. From different direction, if we apply the force, then also the distance between the 2 points remains the same in case of rigid body. This is the definition of rigid body in particularly physics. So this is your rigid body dynamics. This is your rigid body behavior. We will try to understand that how rigid body behaves in a different manner and what is the physics behind the rigid body, that we will try to understand. If we analyze the motion analysis will make us understand what we have already read in the previous classes, that motion can be in the form of translation. What is translation? Suppose a body goes from position P1 to position P2 under the action of some force with uniform velocity, then what you will observe that each point in the body has the same velocity. If its velocity is v, the body will have the velocity v. All the parts of the body, rigid body, that means which is system of particles, many small objects or point objects are there that constitute the rigid body. So all will have the same velocity v. whether we talk about this, whether we talk about this, whether we talk about this, all has the same velocity and velocity vector. So magnitude as well as direction of the rigid body and its constituent remains the same. It is a straight line path. This is called pure translation. This is called pure translation. Now what is important to understand here, that in pure translation, here we have considered the straight line path, but it is not essential that always there will be a straight line path. We can consider a path in this way also, that here also you will observe that the body and its constituent particles have the same velocity. Here also the distance between two bodies, points remains the same in case of rigid body, as well as the direction of velocity and its magnitude remains the same for the whole body. Well, I am talking about the whole body. If this is the different parts we are considering, then each part will have the same velocity v. Here each part will have the same velocity v in magnitude and direction. So this is also your pure translation. This is one type of motion that we should understand very carefully, and that we have read in kinematics in detail, that this is the pure translation type of motion. This motion is called pure translation along a line where all the constituent particles of the body will have the same velocity. That is, if v is the velocity of the body, then its constituent particle will have also the same velocity v. Second type of motion, we can consider that the body is fixed about this axis. The body is rotating about this axis. This is the axis and the body is rotating. Here also we are considering 2 points A and B. If we consider 2 points A and B, what you will observe? You will observe that A is also rotating about the fixed point and B is also rotating about the fixed point. But here the motion is circular. See, here B has a circular path. If you talk about A has also circular path. It is a different matter that the radius of the two paths is different. So if we consider this distance as RA and this distance we consider as RB. So in this situation, every particle, every constituent of the body rotates in a circle. So it is the circular motion. Every particle has the circular motion, and you can understand that the radius of the different particle is different, and in this way the circular motion knowledge is also required to understand this type of motion, and this motion is called pure rotation. So this motion we call as pure rotation. So in this motion what is required? The main thing to be understood is there that in case of pure rotation, whenever we are talking, that is definitely about a fixed axis. And if the fixed axis is there, about the fixed axis, all the constituent of the body, rigid body, they are performing circular motion. It is important to understand that each constituent of the rigid body is rotating in a circular path. It is in its circular motion, but the radius is different. And the body is rotating about a fixed axis. And this motion is known as your pure rotation. So one is the pure translation and one is the pure rotation. Here one more thing needs to be understood, that if it goes from A to B, the angle covered by B in reaching from this position to this position, and the angle made by A in reaching from this position to this position on the circular track, that angle remains same. So when angle remains same, what we can consider? We can consider that the angular velocity omega remains same. But if we talk about the linear velocity, in the circular motion you have read that linear velocity v omega into r. So when v is equals to omega into r, what you can say, if you talk about va is omega ra and vb. So here the main thing to understand here, va is not equal to vb. Omega A is equals to omega B, but VA is not equals to VB. Whereas in case of pure rotation, VA was equals to VB. And here radius is different. Radius of the circular track on which it is moving, A and B, is different. So the velocity of A is different from velocity of B. And as you understand that RB is greater than RA, so velocity of B is more than velocity of A. If I am talking about linear velocity, so linear velocity is more for B than A. So this is the circular motion that has been included here, and it is about the pure rotation. If we talk about the another kind of motion, you might have definitely observed the motion of the wheel of a car. The motion of a wheel of a car that rotates also and at the same time moves also. So that motion is also a different type of motion, and we call it as the combined translation and rotation. Now you can observe that in this motion, the wheel is rotating at the same time moving ahead also, as I told you. So this is your rotation and this is your translation. So this is your translation plus rotation, and this is called rolling. So rolling is a special type of motion in which translation is also there and rotation is also there. This motion is called rolling motion. So finally concluding, we have discussed what is translation, pure translation. We have discussed what is pure rotation, and we have discussed the combined, what is rotation and translation combined, that is rolling motion. Now you have seen that circular motion is there. So circular motion has certain angular parameters and translation motion has its own parameters. How they are related and what sort of analogy is there between circular motion and rotational motion, in fact linear motion, translational motion, that we will try to understand. So here is the linear variable. I am trying to give you a simple analogy between the linear variable and the angular variable. Here the first variable we will talk about the distance or displacement, or in fact the position. So first variable, that is the simplest variable, is the position, which is measured in meter, and then here is the angular position, which is measured in radian. If we talk about the second variable, velocity is v, that is rate of change of displacement, position with respect to time, unit is meter. The angular variable is the counterpart. Analogous quantity is the angular velocity in terms of angle change per second, and that we know that is called radian per second, unit is there. If we talk about the third variable, we can talk about acceleration. If we talk about the acceleration, this is your linear acceleration, which is rate of change of velocity. It is your angular acceleration denoted by alpha, and it is your rate of change of linear angular velocity, that is radian per second square. Now you know that these two quantities are basically vectors, and this is a specific type of vector which is known as axial vector. So one is the axial vector. Regarding axial vector, you should know that here the axis of rotation is there, so it is along the axis. It may be outward or inward. That we understand by right hand rule. What is that? Suppose a body is moving in this way. If we talk about the direction of the angular velocity, this d theta it has made. So if we talk about the angular velocity, we have to use our right hand, and in the sense of rotation we have to curl our finger, and if we curl our finger in this way, the direction of thumb gives the direction of the axial vector. That means the angular velocity will have this direction. If we will turn our curl in the direction of motion, and then the direction of thumb will give the axial vector. So this is the direction of the vector, that is the angular velocity. At the same time, as it is the common way of representing this is in this way. This means that perpendicular to the board and in outward direction. Similarly, if we change the sense of rotation, in this situation, the angular velocity will have this direction along the axis, but we will have to curl our finger in this way, and we are curling our finger in this way, and the direction of the axial vector, that is angular velocity or angular acceleration, whatever we are taking the angular variables which are axial vector. So here it will be the direction that is cross. This is inward. Perpendicular to the board, inward is being represented by this, and perpendicular to the board, outward is represented by this. So this fact also will be helpful to you people in understanding the direction of the angular variables. Now in the linear motion, we talk about mass, which is measured in kilogram. Mass is a factor, is an entity that tells you the difficulty level in changing the position of a object. So if a higher mass body is there, then changing the position of the higher mass body is difficult as compared to a smaller mass body. You can move pen from one place to another place in a very comfortable way. But if you have to move the truck or car from one place to another place, it appears more difficult. So we call it as inertia. So mass defines the inherent property, depends on the inherent property inertia. In the same manner, it basically tells about the difficulty level in changing the position of an object, and same difficulty level is being expressed, or degree of difficulty is being expressed in the rotational motion, that is I. That is the same difficulty level in rotation motion. It appears difficult. Why it appears difficult? Because in rotation motion also the degree of difficulty is based on a factor, and that factor has got the name of moment of inertia. So here mass, what role mass plays in linear motion, the same role is being played by moment of inertia in rotational motion. So in moment of inertia is a quantity, new term is there, but it is a quantity that basically tells you about the fact that how it is difficult to rotate a body. If in rotating this body the difficulty level is less, that means moment of inertia is less. But in rotating some other body, if the difficulty level is very large, then you will observe that the moment of inertia is large. Now, what are the factors on which this moment of inertia depends? That we will talk later after defining it. Next term that we would like to tell you, here we talk about force. Mass into acceleration. Force is the cause of motion in translation motion, in pure translation. The similar counterpart of force here we call is as torque. Torque. The symbol is tau. Torque is the counterpart, or in fact the analogous to force in rotational motion. Moment of inertia has the unit kilogram meter square. Torque has the unit Newton meter. So torque is a different quantity that we will understand in a better way, in a detailed manner in this rotation chapter. And similarly, you can take the torque Newton meter. Here it is mass into acceleration. So it should be mass should be replaced by moment of inertia, and acceleration should be replaced by angular acceleration. So mass and angular acceleration, that will give you torque. Mass into acceleration, translation motion, torque, moment of inertia into angular acceleration, that will give you torque. Now the next thing is there, one more thing. If we talk about kinetic energy gives half mva square. This is the kinetic energy in your pure translation. Velocity is the body. Similarly, you can write kinetic energy rotational. Kinetic energy rotational. This can be half, at the place of mass it should be moment of inertia, and at the place of velocity it should be angular velocity square. So kinetic energy can be given in this way. This way you can understand, and you are understanding that rotational motion and linear motion has some analogy, some sort of relation, and similar type of phenomenon what is observed, what are the quantities, what are the variables defined here. The similar type of variables are defined in your rotational motion also. So here our main focus is on moment of inertia. What is moment of inertia? Moment of inertia is basically the degree of difficulty level, or in fact the difficulty level in rotating a body. So when we want to rotate a body, it needs some type of effort, and that effort's difficulty level is represented by a quantity in physics, and that we call as moment of inertia. So moment of inertia of a body we will define just now, that how it creates the difficulty level. And you might have observed that moment of inertia definition, which we are going to explain just now, will tell you the fact that how much difficulty level is there in rotating a body. For example, if you are taking a cylinder, take the example of a cylinder. If the cylinder is taken from here to here, one place here to one place here, in this manner, in the rolling manner, then the matter is different, difficulty level is different. And if it is taken in this manner, then the difficulty level is different. So if the cylinder is taken in this manner, then the difficulty level is different. And if it is rolled in this manner, then the difficulty level is different. Why? Because it is a fact that in the process of rolling in this manner the cylinder, the effort level is different, and in rotating the cylinder in this manner, the effort level is different. So that effort level is the fact that tells about, that will give you the meaning of moment of inertia, which we will try to understand in a very comfortable way right now. So the main course of our discussion is now the moment of inertia. First thing you should know that for our consideration, we will treat it as a scalar quantity. So the scalar quantity is there, so we will use the scalar algebra to scalar mode of mathematics to treat the moment of inertia. Unit is your kilogram meter square. Now, as I told you, from its definition, as has been defined, suppose we are taking a rigid body, and here is the axis of rotation. So as this is the rigid body, it has system of particles. So many large number of particles are there. We are considering few particles. So many particles are there, and it is rotating about this axis. It is rotating about this axis in this manner. If we talk about the kinetic energy of this system, if we talk about the kinetic energy of this system, half F1 V1 square, half M2 V2 square, and so on. Infinite number of particles are there. So many particles are there. Infinite number of particles are there. So we will explain in this way. Now you understand the linear velocity is different. Linear velocity is different, but angular velocity remains the same, because each particle is rotating in a circle. Each particle has a circular motion. So if we replace V is equals to omega into R, then we can get it in this way. See here, I have taken the omega same, because angular velocity of all the particles performing circular motion will remain same. Linear velocity will be different. And then we can get a relation in this way. You can get the relation in this way. Now, if we remember the expression of kinetic energy, Ke is equals to half m into v square. It is also, as we are talking in terms of rotational motion, so here also something is like that only. What is that? Velocity square is there, half is there, and this is the playing the role of mass, and here we call as I, that is moment of inertia. So if we take this, then we will be getting kinetic energy must be equals to half I omega square, where I we can define a new quantity, that is the moment of inertia, and this moment of inertia for n particle system of the rigid body must be equals to m1 r1 square, m2 r2 square, and so on. And in fact, we can, if we write in the summation format, then it is mi ri square, where I is equals to 1 to m. If we talk about a single particle, at a distance r1, or better you say r, about this axis of rotation, then moment of inertia will be simply mr square. So moment of inertia from here also, you understand, m is in kilogram, r is in meter, so unit is kilogram meter square. And this basically represents the factor that how much is the difficulty level in rotating the body. If a heavy body is there, difficulty level will be more. If a lighter body is there, the difficulty level will be less. Now think and imagine, what are the factors on which this moment of inertia depends? First, the position of axis. That which axis, if I am taking this axis, the moment of inertia will be different. If I am taking this axis, the moment of inertia will be different. Second, the mass. Third, the dimension mass distribution, and mass and position of mass also. How much mass is there? So this fact you should understand in a very careful manner, and that I will write also. So we can understand in a proper way that moment of inertia of a rigid body depends upon these factors. Just now we have seen in the discussion that if axis of rotation is changed, then the moment of inertia changes. What does it mean? It means that if the axis of rotation is in this way, then moment of inertia is different. But if the axis of rotation is in this way, then the moment of inertia is different. It also depends upon the distribution of mass, that how the mass is distributed. And because we have seen that in the definition of moment of inertia, we come across with the quantity I is equals to mr square, or sigma mi ri square. So distribution of mass is also important. Dimension means shape and size of body. If the body is large, then also the moment of inertia is different. Distribution of mass is basically the mass density, how the mass density is there. And also distance of mass from the axis of rotation. If the distance of mass is large, then the axis of rotation, if the distance of mass is large from the axis of rotation, then the moment of inertia will be different. If the distance of mass from the axis of rotation is different, the moment of inertia will be different. So these are the factors that you should understand very carefully. And the fundamental definition that we have understood, I is equals to sigma mi ri square. If there is only two mass, then I will be m1 r1 square plus m2 r2 square. R2 is the distance of mass m2 from the axis of rotation. R1 is the distance of mass m1 from the axis of rotation. This is the basic fact about, basic fundamental definition of your moment of inertia. Now we will try to solve few examples just to understand the concept of moment of inertia in some better way. So what is that? Try to understand. Suppose if I am taking two mass system, one mass is here and another mass is here, and this is the central position, and here the axis is in this way. Axis is in this way, which is passing through the center, and let us take this distance to be 10 meter, and this angle we are taking 37 degree. If we are taking 37 degree, you have to find moment of inertia of this system is how much? Moment of inertia of system. And this system comprises two mass. In this situation, you should understand very carefully that in physics, the two angles 37 degree, and we can write it at 57 also, 53 also, 53 also, you can use it. That will be some other. In the discussion of physics, as you have remembered the 0, 30, 45, 60, 90-degree value of trigonometrical ratios, in the same way you have to remember 37 and 53-degree also. Why I am telling this thing to you people? If we consider the triangle in this way, this is 37, this is 53, this is 90, this is 3, this is 4, this is 5. Then for finding sine 37, cos 37, tan 37 or sine 53, cos 53, tan 53, you are not supposed to use your calculator. You have to remember this value, that sine 37 degree should be equals to 3 by 5. Directly you can use this value. Similarly, cos 37 should be equals to 4 by 5. And you can use for, because for 37, this is your perpendicular, this is your base, and this is your hypotenuse. And for 53, this is your perpendicular, this is your base, and this is your hypotenuse. That should be clearly understood, because these two angles are very useful in solving the problem of physics, and they are used in physics frequently. So you should understand this value also. I have said here two mass system is there. When here two mass system is there, moment of inertia should be 2 mass for first mass plus for second mass. Question is, as I said, 2 mass system as it is a scalar, so for first mass moment of inertia, and for second mass, first mass you will write m r1 square, second mass you will write m r2 square. Why? Because mass remains the same, mass is same, so m r1 square plus m r2 square. Also you should understand very carefully that this r1 r2 are basically not any distance, it is perpendicular distance from the axis of rotation. This will give you r, and as it is symmetric, so this will be your r. So r1 is equals to r2. In this case, r1 is equals to r2. And if we take r1 is equals to r2, then it will be simply your 2m r square. Now the problem arises how to find the value of r. As I told you, this is 10, this is 5, this is also 5. So 5, so this is 37. If we take 37 value, then this value should be 3, this value should be 4. Similarly, this value should be so this value is 3, perpendicular distance is 3, that is 2 into m into 3 square, and this is giving you 18m. 18m is the value for 37 degree. If you take the case of 53 degree, what will be the value? Similar, r value will be for 53 degree. For 53 degree, r will become equal to, now I am taking 53 degree. This will become 4, 3. So for 53 degree, r will become 4. And when r will become 4, here we can replace by 4 and we can get I 53 degree. When the axis has 53 degree, 2 into m into 4 square, that is your 32m. So this is the basic fundamental question that will tell you how we can use the moment of inertia concept. For clarifying the concept of moment of inertia, this numerical we have used to understand the concept that what does it mean by sigma mi square. Hope with this much amount of discussion, the fundamental and basic understanding of your moment of inertia concept definitely had been cleared to some better extent. More revision, more practice and more effort will give you further more clarification. Thank you. Have a nice day. We will be meeting again with the second lecture of moment of inertia in our next video. Thank you.